This video is for Monday, August 15th in Math 1324. We don't have a usual week, but we'll be doing homework the first 2 days instead of the first 3. So today, Monday, I plan to do half of the week 5 homework. There's only 30 problems in there, 1 through 15 today. Tomorrow we'll do 16 through 30. And then Wednesday we can do the entire review because it's only like 20 or 25 problems. So since we normally have 3 days of learning new stuff, so I didn't make videos for reviews in the past, but I'll go ahead and do this one because we have an extra day and it's the review for the final, so that would probably help. Okay, so homework week 5. Only 30 questions here. There's no test over this separately, but some of this stuff will be on the final exam. So we're going to be working with some systems of inequalities now instead of equations. That's the big difference here, is there's an inequality. Determine whether the ordered pair is a solution of the inequality. We did a very similar thing like this for equations. 5y minus 6x is greater than or equal to 7. And supposedly somebody wants to think that 220 is a solution. And in equations, we often got one solution. Now what's different is there can be an infinite number of solutions. It's a whole interval of answers. But this is just one particular thing that could be a solution. So I have an x and a y. I'm going to plug the x in there and the y in over there. Just they have it out of order, but be careful about that. So 5 times 20 minus 6 times 2. This would be 100 minus 12. This is 88. The left side of the inequality is 88 if I plug these numbers in, and the inequality says that the left side is supposed to be greater than or equal to 7, and it is greater, so that is true. 88 is greater than or equal to 7 because it's greater than 7, and that means this is one of the solutions to this inequality. So just like with equations, you can check solutions sometimes to see if you have it right or not. So if you thought that was an area where the answers are, that shows that it is true. If you check it and it's not true, then you know you made some kind of mistake. Okay, we graphed equations earlier, so this is graphing a inequality, but you treat it like an equation at first. So if you had y equals x minus 8, the minus 8, that's the y-intercept. So you still click the line tool, go down to the y-intercept, which is -8, click that. The x is where the slope is located, so right in front of the x is a 1, and then I could make that 1 over 1, so that way the slope from this starting point would be up 1 and right 1. This is how we graphed, one way we graphed lines in previous chapters. You get the y-intercept, and then you do the slope and get another point. Here's all that's different when you have an inequality. The equal to part of this is basically the line. So you can have greater than or equal to, or you could have less than or equal to in the original problem. Both of those are solid lines, just like if you have an equal to. If it's just greater than or just less than without the equal to, then you never saw this before, but you get dotted lines. That means stuff on the line itself is not in the solution. If you get either of the greater than options, after you draw your solid or dotted line, you're going to shade a whole portion of the graph upward. Greater than's up, less than is down, which probably makes sense. Often the lines are diagonal, so Don't think of it as left or right. You always want to think of it as up or down. So if this was just greater than, I would change from a solid line to a dotted line by clicking this and see how it's a dotted line now. We'll get some of those later probably, but I'm going to keep it as a solid line. And then you click this little paintbrush right next to the lines, and it allows you to go up or down. Don't think of it left or right. Think of it as up or down. Then you'll get it right more often. So greater than's up. I just got to click anywhere over here, and it makes that whole area yellow. So literally anything on the line or anything above it is in the solution set. And then I could do like problem number 1 and pick some coordinate like say 0, 0 or 1, 0 or 0, 1, 0, 0 and see if that's true if I put 0 and 0 in here. Is 0 greater than or equal to 0 minus 8? Yes, it is, because 0 minus 8 is negative 8, and 0 is bigger than negative 8. So that shows that 0, 0 is one of a whole many infinite number of solutions, but that makes sure you shaded the right half of the graph. So you want to make sure when you're doing this, like number 2, you got to have y by itself. Or you need to use the intercept method. I'll show you both ways to do this. 3 has 6x plus 2y. 6x plus 2y is less than or equal to 12. The main way to do this is solve for y. And anytime you have both an x and a y, this is always a good method. Sometimes the intercept method is less work, but that doesn't work every time. This works every time when you have a diagonal line. Divide. Now here's a key thing. If you divide by 2 to get the y by itself, you just treat this like an equal sign all the way down, with one exception. The only exception for inequalities compared to equations, if you multiply or divide by a negative, not with a negative, but by a negative, then you flip the inequality. And that is very important, because otherwise you'll shade the wrong way if you don't do that. Or if you do it when you're not supposed to, that will mess it up too. So it's not if you just see a negative somewhere in a division, that's not when you flip it. It's if you divide or multiply by a negative. I'm dividing by positive 2 right here. This is dividing by positive 2. So I don't flip it because of that. It's going to stay less than or equal to. And 6 divided by 2 is 3. 12 divided by 2 is 6. So this would have a y-intercept of 6. And then I can put this over 1 and go down 3, 1 to the right. Down 3, 1 to the right. And it's a solid line because it's got the or equal to. And it's less than or equal to, so you shade downward. And some students, when they do it by hand, they get afraid to cross these axis lines. So they'll leave this little triangular formation unshaded, but that should be shaded too. You want to get to the diagonal line and shade everything below it. And it would continue forever, so this is definitely one way you can do it. Another way is you can plug zeros in for x's and y's one at a time. The only downside to that is if you get a problem where, well, there's two downsides. If 6 and 2 don't divide into 12, then that's not a good method, no matter what's happening. And the second thing is, in inequalities, sometimes the inequality flips the other way because you divided by a negative. And if you do the intercept method, you might not know when that's happening. But if you see everything's positive, then it's safe to do the intercept method if they divide evenly. So put 0 in for 2y. This will disappear. You'll just be left with 6x equals 12. And you can just think of it as equal for a second. 6x equals 12. So divide by 6 and x equals 2. So you can do that. You click your line tool. X equals 2 is right there. Then you put 0 in for x. The 6x disappears. 2y equals 12. So y equals 6. And we had that from the other method too. Y equals 6 is right there. And notice I can go down 3 and over 1, and that's how I did the other method. I landed right there. But if you repeat that, down 3 over 1, you land on the line again. And then because it's less than or equal to, and the inequality did not flip, less than is when you go downward from the diagonal line, not upward. So it's over here on this side. And notice even that little triangle area is filled in too. So 2 different ways you could have done that problem. Get the y by itself, get the slope and the y-intercept, or just find the 2 intercepts if they come out evenly. Okay, you're going to get some word problems where you're going to do these graphs and look for certain spots on the graphs. So in the word problems, they're going to have expressions that correlate to inequalities. So if you don't know which one goes with which, then your graph's going to be all wrong. There are fewer than 16 employees. Use the letter M to represent the number of employees. So the number of employees, M, is fewer than. Fewer than means less than. It's not greater than, it's not less than or equal to, it's not greater than or equal to, it's just less than. And then you would possibly do a graph after that, but this is just about learning how to take the sentence in English and turn it into an inequality. The price is at most $5,500. Use P for price. So price is at most, which is one of these 4, and then you put 5,500 after that. Now, many students get at least and at most mixed up. Here's how I remember this. At least versus at most. Think of associate at least with driving a car. I always think of that one, that's driving cars. You have to be at least, you have to be at least 16 to drive a car. Say that to yourself a number of times. You have to be at least 16 to drive a car. Who's driving cars? 16 down to babies or 16 up to adults? So we know there's no babies driving cars. So at least can't be 16 and down. It's 16 and up. If you're 16, 17, 18, 100 years old, or however old people can live, they could still drive potentially. So if you're 16 or older, at least you're eligible to drive. It's not that everybody that does drive, but you have to be at least 16 to drive a car. So remember, at least is 16 and up because that's who's driving cars. So that means at least is greater than or equal to. You can be 16 exactly or higher than that. At most is the other one, less than or equal to. So if I get one that's at least, I know that's the one that's that and higher. If I get at most, it's the other way around. And what makes it confusing is least sounds small. So students want to put less than for that for some reason. Most sounds big. That sounds like you should put a greater than. But it's not least and most. It's at least and at most. At's kind of like not. If you're not the least, then you're the other way. You're higher or equal to that spot. If you're not the most, then you're lower or equal to that. So that's how, this is not hard, but if you get the wrong one at the wrong time, then the whole graph's going to be wrong. So this is at most, and it's not the one for driving cars, so that's the less than or equal to. Okay, then what they do is they reverse this process. Now they have a graph drawn, and it's shaded, and we want to pick out which inequality would that be. Well, we could maybe get this right just from the way the shading's happening. There's a solid line right here. So it has to have an equal to in it. It's definitely not A or C. Those are definitely out. And it's shaded downward. It's mostly to the left, but think of it as shaded downward from the diagonal line. So that would be less than or equal to, unless there was a flipping of the inequality. So that would be the only issue. Is if I look at the inequality, I can see the y-intercept, -7, and the slope is from any one point like here. Well, for sure it's down 1, 2, 3, 4, 5, 6, 7 over 2. So for an equation, it's definitely y is less than or equal to down 7 over 2x minus 7. Because I can see the slope in the graph and I can see the y-intercept in the graph. And then you need to put this in standard form, so add this over to the other side. Standard form is when the x is first, the y is second, and the numbers last. And then two unwritten rules. You never put the x as a negative in the final answer. So if x is negative, you just multiply everything by -1 to make it positive. But if you do that, that would cause the inequality to flip. And then they don't like fractions in the standard form either. But if you have just one fraction, then you multiply everything by that denominator. Multiply everything by 2. And that would cancel the 2's right here. 7x, 2y. I'm multiplying by 2, so then I don't flip it. But if I multiplied by -2, I would have to flip it. And then even though it's 2 times -7, you don't flip that. It's not if you multiply with a negative, it's if you multiply by a negative. So this would be the inequality. And if you see in the choices that they're all positives, the 7 and 2, they're all positive. So then that means there's not going to be any flipping going on. So it was this one all along where it was less than or equal to. But I did work it out and get the same answer they have. But you could have known the answer was D because it was a solid line. That it definitely eliminated A and C. And if it's shaded down, you're probably going to have a less than, but you just have to be careful that there wasn't a flipping of the inequality at any point. So just because it's shaded down doesn't mean the answer in standard form had a less than in it. Okay, here's a horizontal line. Remember horizontal asymptotes, vertical asymptotes? All horizontal lines are y equals whatever number you're passing through. And all vertical lines are x equals whatever number you're passing through. This dotted line is horizontal and it's passing through 1 because there's 1, 2, 3, 4. So if it was just a line, the equation would be y equals 1. But it's a dotted line and it's shaded down. So that is y is less than 1. Less than, not less than or equal to because it's dotted, and less than is down, greater than is up. Okay, so when you get to the word problems, what's going to happen is they're going to give you one or more of these main inequalities. Here we just have one. And then in the word problems, they always do this right here. This x is greater than or equal to 0, y is greater than or equal to 0. What that does is that keeps you in the first quadrant. X greater than 0 is a vertical line on the y-axis, and greater than for a vertical line is to the right. That's the one time you go right or left. And then y is greater or equal to 0, that's the x-axis, and greater than's up. So if you're above the y-axis and to the right of the x-axis, you're in the first quadrant. And the reason for that is we're going to do problems where it's like It costs us $12 to make a pencil, and it costs us $20 to make a pen if we take all of our costs. We're a business and we take all of our costs into account. So we have to buy insurance, we have to rent a store, we have to pay our employees. So all the expenses total cost us $12 for every pen we make, pencil, and $20 for every pen, or maybe it's cents too. 12 cents for every pencil and 20 cents for every pen. How many pencils and pens can we make so we keep our costs at a minimum would be an example of a problem that we're going to see later. And you can't make negative numbers of pencils and pens. They could be 0, but they can't be negative. So that's why you're in the first quadrant, is the pencils and the pens both have to be 0 or positive. So that's not what this problem's about, but that's what's going to happen. So what you can do is you can immediately do the line tool and click any 2 spots on the y-axis. That'll be a solid line for this. And then do it again and do the x-axis. That's this one. And then, because these numbers are so large, I'm going to try the intercept method here. 12x plus 20y is less than or equal to 1200. So if I put 0 in for y, I'm going to get the x-intercept if it comes out exactly. So 12x, and you can ignore the less than for a minute, 12x equals 1200. Divide by 12. That's exactly 100. And if you didn't know that, 1200 divided by 12 is 100. And then when you put 0 in for x, then this whole part disappears. So you're left with 20y equals 1200. Divide by 20. $1,200 divided by 20 is exactly 60. Anytime you have a x to the first and a y to the first, that's a diagonal line. If you just have x or you just have y to the first, those are horizontal and vertical. But many of these are x to the first and y to the first, they're diagonal lines. So if the x and the y-intercepts come out exactly, then that's the easiest method. And especially if everything's positive here, there's no chance that I could have a flipping of the inequality going on. If there was a minus sum in here, then I would probably want to solve for y the old-fashioned way. But I can click on x is 100 and y is 60 on this graph with a line. X is 100, y is 60. So let's see, 10, 20, 30, 40, 50, 60. And then it looks like this one's going by 50s. 50, 100, 150, 200, 250. So 100 would be the second spot. There's your diagonal line. And you need to be above the x-axis so that you have a positive. You need to be to the right of the y-axis so you have positive, because you can't make negative amounts of product. And then the inequality they gave me was less than or equal to for the diagonal line. So the diagonal line is solid because of the or equal to, and less than you shade down. But you're going to stay in the first quadrant. If they didn't put these two, then it could keep going below that, but it's in the first quadrant. So it's this little triangle area right here. That's what we call the feasible region when we're going to be solving some word problems later, where we want to find what's going to help minimize this cost for our business. We want to minimize our costs so we can maximize our profits. And the good news is once you get a feasible region, the answer is in there somewhere. So I don't need to check anywhere out here or any of this stuff out here. It helps narrow the search down. Okay, now this one's greater than instead of less than or equal to, but they still have these two, so we're definitely in the first quadrant. So I'm going to do the x-axis and the y-axis. And we're going to stay up here only. Most of the problems will have this attached to them. So if I want to get the x-intercept, I plug 0 in for y. And then you would have 15x equals 1500. So x is 100, which is right there again. And then if you put 0 in for x, this disappears. And notice there is a negative there. But if I just do the value 1500 divided by 25, that's 60 again. Now that's just a coincidence that those came out the same, but there is a negative here. So that's going to mess it up, because then we would miss which way the shading is going. 15x minus 25y, 25y is greater than 1500. You might think that that should be shaded upward, but it's going to turn out to be downward again, because if I subtract 15x negative 25y, and I always put the x part first and then the number last, so that way it looks like mx plus b. Here it is. I'm dividing by negative 25. I am dividing by negative. That's when the inequality has to flip from greater than to less than. These two negatives make a positive, and these both divide by 5, so you could get 3/5. And 1500 divided by negative 25 is negative 60. So you would start at negative 60. Negative 60 on the y-axis, this is where you start your graph if you're doing this method. Start at negative 60 and go up 3 and 5 to the right as many times as needed. And that might actually be hard to do here because the graph is in such large numbers. But then the x-intercept could help. Remember when I found the x-intercept? The x-intercept was when I plugged 0 in for y. 15x equaled 1500, so x was 100. So I can put the negative 60 y-intercept, which is right there. It's hard to go up 3 over 5 here because it literally jumps you by 10. It won't even let you go up 3 over 5. But we knew that the x-intercept was 100, so that has to be right there. And then the, whoops, not there. The inequality switched to less than when I divided by a negative. So then you're shading down. It should be a dotted line and shaded down. So I do need to change that to a dotted line too. Dotted line shaded down. But you're going to stay in the first quadrant. So actually it's this right there. You're below the dotted line, but you're in the first quadrant. And this goes forever. So unlike the previous problem, unlike this problem, see how the area is enclosed? If the area is enclosed, then it's guaranteed you're going to get a maximum and a minimum answer. But if it's unenclosed, which they call unbounded, if this just continues forever, because this will go on forever, the graph cuts off after a while, but it actually would not keep, it wouldn't stop there. It would just keep going forever. You need to have lines crossing each other enough to have a closed area like possibly this here. But we're never down here in this quadrant. It's always the first quadrant. So this is an unbounded region going up forever. Then there's no maximum. There can still be a minimum, but there's no maximum in that case. So that's the two things that happen when you graph these, is you're looking, did you get an area that's enclosed or did you get an area that's unbounded? So here's the full word problems, although I don't think we're solving it yet. I think we're just setting up the graph here. A company produces foam mattresses in two sizes. They have regular and king size. So that's the X and the Y. regular and king size. It takes 8 minutes to cut the foam for a regular mattress and 6 minutes for a king mattress. So literally you want 8x plus 6y for that. 8x plus 6y, not 6x plus 8y. B and C are wrong. And of course they all have this, notice they're all in the first quadrant because you can't have negative numbers of mattresses. If the cutting department has 80 labor hours available each day, so that's all they have is 80, they can't go over that. It's 80 or less. So that's why the answer is D, is you have to stay at or below 80. That's all the money they have to spend on labor every day. If we had unlimited resources, we could make all the mattresses in the world, but we have the costs of buying the materials, we have the costs of the labor to pay employees. So these are called constraints. You're constrained to this here, and your solution when you're looking for how many regular and how many king size should I make to maximize my profits or minimize my costs, it's constrained by certain things, whatever's in this paragraph. How many regular and king size mattresses can be cut in one day? Okay, so this is the inequality we have to work with. So we had to read this paragraph to get what the last two problems started with. The last two problems just told you these things right here. You had to read this and figure out that it was D first, but then you're going to make the graph the same way. Whoops. Did I say it wrong? 8x, 6y, 80. 80 hours available each day. Is there another choice? No. Oh, I know why. Yeah, see, they caught me. It's a units issue. The 80 is hours, but the other two are about minutes. It takes 8 minutes and 6 minutes. So we need to, if we're going to put 8x and 6y, that's minutes, so then this has to be minutes too. So 80 hours is correct, but it's not correct in that inequality, because you have to do 80 hours times 60 minutes in an hour. That's 4,800 minutes. So the entire inequality has to be about minutes. You can't have minutes for the left side and hours for the right side. That's why D's wrong. See, they tried to trick us with that, and it tricked me. I wasn't even paying attention to the units. Okay, so then now we're going to graph this like we did the last two problems. So everything's positive. I can do the intercept method. And if you plug 0 in for y, you'll be left with 8x equals 4,800. 4,800 divided by 8 is 600 for the x. The x is 600 right there. And then if you plug 0 in for x, you'll be left with 6y equals 4,800. So 4,800 divided by 6 will get you the y-intercept, 800. And of course, we need the x and the y-axis too. And then the key thing is this is always first quadrant. This is definitely not going to flip because I have all positives. So you're definitely less than or equal to on this diagonal line. So the or equal to is the solid line, and the less than would be below. But you got to stay in the first quadrant. So this is an enclosed area, this triangular region right here. That's our feasible solution. The solutions are in there somewhere. It's enclosed, so we're guaranteed to get a maximum and a minimum. What's the maximum number of, what's the maximum, like profit, for example? We haven't got to that part yet. They have to give you more in the problem to do this, the ending of this, but eventually we're going to say, what's the maximum profit our company can make with these constraints that are given to us? And then how many regular mattresses and king mattresses can we do to have that maximum profit occur? That's where we're getting to eventually, but it's not happening yet on this problem. Okay, so we'll get to there, I guess, tomorrow when we do the second half of this. Okay, so now again, they're just going to have you practice some more graphs. Now what's going to happen is now there's going to be more than one of these inequalities that aren't the x and the y-axis. That's what's happening in this next section. So I actually have two inequalities that are not the x and the y-axis. 4x plus y is greater than or equal to 8. And then there's one that's a vertical, x is less than or equal to 1. Because that doesn't have a y, that's a vertical. So I could do the mx plus b method and get y by itself. This does not have the first quadrant restriction. There is no x is greater than or equal to 0 and y is greater than or equal to 0. So now I can land in other quadrants. The y-intercept is 8. 1, 2, 3, 4, 5, 6, 7, 8. And the slope is negative 4 over 1, so you go down 4 over 1. And you could do it again. Down 4 over 1. It's greater than or equal to, so that would be a solid line. And you would shade up, even though it's close to vertical, you're shading up. If you just had that one. So that's what the last section, problems 1 through 10, they only gave you one main inequality besides the x and the y-axis. So now you're going to have two or more inequalities, and then maybe even the x and y-axis too, but this one doesn't have them. So x is less than or equal to 1. If you remember x equals 1, remember that was a vertical line. X equals 1 is a vertical line right through 1 on the x-axis. Now, if you get a diagonal line or a horizontal line, then greater than you shade up, less than you shade down. You can't shade up or down on a vertical line. So that one's the one time you do left or right. And this is even pointing which way it wants you to go, to the left, less than to the left. So I want to be to the left of the vertical line, but above the diagonal line. So some people do it this way where they go to the left of the vertical line all the way down. And then they go above the diagonal line. And you're looking for the spot where there's a checkerboard crisscrossing going on. This region right here between that little wedge, that's getting shaded twice basically. You got this part that's only shaded once, this part's only shaded once, but there's two shadings going on in that middle portion. That's the solution. And then, so you might do that in your scratch paper first. And then here I'm gonna go up to 8, down 4 over 1. And then I need another line that's just vertical at 1. And then when you paintbrush, when you have two lines, you always either paint the top portion, the bottom portion, the right or the left. So this is the top portion, like that. But if you do it on your scratch paper first, you might be able to tell better which one. It's hard to know which one of those four it is just by looking at it. So it helps to do that where you're going above this line. And then maybe later you'll get another one that's diagonal too. And then say you're going above that one. And right where you see this crisscrossing going on, that's the answer. So that's the top portion of the graph where the crisscrossing is happening. This was a little different because the other line was vertical, but. Okay, see now we have two of these. These are going to be two diagonal lines that make a big X. You're going to get a big X like this, and then you shade either the top only, the right only, the bottom only, or the left only whenever there's two lines like that. X minus 4y is greater than or equal to -8. And then I'll do the other one next to it. 2x plus y is less than or equal to 6. So the second one's easier. You just have to subtract 2x. And now the y is by itself already. If you ever add or subtract, the inequality definitely never flips. It only flips if you multiply or divide by a negative. So this one would be a y-intercept of 6. And you would go down to 1 to the right. Right there. It's less than or equal to, so that's a solid line. And now the x's don't matter, so they're just there for our graphing purposes, but they're not any kind of restriction or constraint in our problem. It is less than, but I'm going to wait a minute to shade it in later, but we're going to be shading downward from this one. So on this one, if you subtract x, negative 4y is greater than or equal to negative x minus 8. Here it comes. I'm dividing by negative 4. I'm dividing by a negative. That's going to flip it from greater than or equal to less than or equal to. And there's a 1 right there. So this is negative 1 over negative 4. That's the same as positive 1/4. Negative 8 divided by negative 4 is positive 2. So you start at positive 2 right there. And then you go up 1, 4 to the right. From this starting point, up 1, 4 to the right. It's less than or equal to, so that's also a solid line. So there's the x. You're either going to shade the top portion, the right portion, the bottom portion, or the left portion. And the main way to tell is do this on a piece of, on the side somewhere like this. And go back to each one of these. This one's less than or equal to, that's the one that started at 2. That's this one that's traveling upward. That one needs to be less than, which means you go downward from that one. And then the other one was also less than or equal to. The one that went this way, you want to go less than or equal to. So now you're going downward from this one. See the checkerboard right there? That's the region to shade. And here's another hint too. If you get to the end and you've accounted for any kind of flipping of the inequalities, so not from the original inequalities, but from the ending inequalities, if they're both less than in an x diagonal line situation, if they're both less than, then you're definitely shading the bottom portion of the graph only. If they're both greater than, you're doing the top portion. It's if 1 is greater than or 1 is less than, which is what the original problem looked like, then you would be on the left or the right, and then it's not so easy to tell which one. Then it helps to do this. But if you knew on this problem, wait a minute, they're both less thans, then I know it's going to be the bottom portion of the graph. Then you wouldn't necessarily have to do this, but if you like this, you can double check it that way. Okay, so let me remember what my lines were. One line had a y-intercept of 2, and it went up 1 over 4. Y-intercept of 2, up 1 over 4. And they're both solid lines. The other one had a y-intercept of 6, I believe. Yep, 6. And it was down 2 over 1. Paintbrush the bottom, most bottom portion of the graph. Not the top, not the left, not the right, but the bottom. Okay, so now we're back to this again. See, the X is greater than or equal to 0, Y is greater than or equal to 0. That's the positive for both of them. So that's the first quadrant. So I'm definitely going to be in the first quadrant for number 13. So we need to be to the right of this and above that. So then there's only one inequality here. 11x plus y is less than or equal to 22. 11x plus y is less than or equal to 22. So if I subtract the 11x, y is less than or equal to negative 11x plus 22. So I'll do it as a quick sketch here, but we'll get a better graph on the computer there. But positive 22 is up here somewhere. That's the y-intercept. And if I go down 11, that would be halfway to the axis. So I'll just estimate it down 11 over 1. This is a less than or equal to, nothing flipped. So that's a solid line. And less than you shade down, except you need to stay in the first quadrant. So you're going down from this diagonal line, but you can't cross the x-axis or the y-axis. Maybe that's where those students are afraid to cross x and y from in other problems. But you can't cross the x or the y-axis only when this is included in the problem. Many problems don't have these two. So then if I look at my sketch here, this is enclosed. I had to stay within the x and the y-axis, and I had to be below the diagonal line. This is a bounded or enclosed region. And that's what this problem's, the only thing this problem's asking is it bounded or unbounded? It is bounded because it can be enclosed within a circle is their definition of it. If you can put a circle around it, and it's entirely inside your circle, then it's bounded. But that problem, where was that other problem that was going on forever? So it's further, maybe I didn't write it on here. But if you got one that went like so, say it went like this. Oops, I went down too far, but there's no way to encircle this because this goes forever that way. You could never draw a circle big enough to enclose all that. So I don't really think of it that way as much as they do, but their definition is if you can enclose it within a circle, then it's bounded. But to me, it's obvious in a picture. I think of it, is it enclosed rather than bounded? Is it entirely enclosed inside of some geometrical figure? Yes, it is. Or does it just continue on forever without stopping? That's really the difference between bounded and unbounded. And the reason that's important is if it is bounded or enclosed, you're guaranteed to get a max and a min later when we do that tomorrow. But if it's unbounded upward, then there's no maximum. You can get a minimum, but not a maximum. And if you weren't restricted to the first quadrant and it was bounded downward forever, then there'd be no minimum either. Okay, so you can't just look at the original problem here on 14. If you just look at the original problem, you might get tricked by what's happening. 4x minus 2y is greater than or equal to 16. And it does have the first quadrant here. Whoops. You might see this greater than or equal to and think, okay, greater than or equal to is this. Normally it is. But you got to be careful if maybe it's going to flip before you get to that point. So I got to get the y by itself first before I decide that. That's why the intercept method isn't always the best method. It can trick you on problems like this. So minus 4x, negative 2y is greater than or equal to negative 4x plus 16. Here it comes. I'm dividing by negative 2, dividing by a negative. So I got the y by itself, but because I divided by a negative, this flips the less than or equal to. And this would be positive 2x minus 8. So that's got a -8 y-intercept, and it's okay if the y-intercept is out of the first quadrant because I'm going to graph a diagonal line here. The y-intercept is -8 down here. If I go up 2 over 1, up 2 over 1, and keep doing that, it's eventually going to reach the first quadrant. And now you need to stay within the first quadrant, and you need to be less than. Solid line equal to, but less than. So the shading is this. So it won't ever go past this x-axis here, but there's nothing stopping it from going out like this. It's just going to keep going forever like that. That's unbounded. So this is unbounded, therefore there's no maximum. And it can't be enclosed within a circle if it goes forever, so it's a little hard to see that from a graph, but because us humans, we don't think infinitely very well, it continues for infinitely to the right and up, so there's no way to enclose it in a circle. Okay, so now here's, okay, I'm going to do this. This will be the last problem for today because then we'll be halfway done with this homework. And then tomorrow you'll see more of this, but this is where you start searching for the maxes and mins. So I've got an inequality here that's all positive. So no chance that I would flip it if I solve for y. So I could easily do the intercept method on that one, because if y is 0, 2x would equal 12. Divide by 2, x would equal 6. So the x-intercept is 6. Then if I put 0 in for x, 3y would equal 12, so y equals 4. And you've got the first quadrant because of those two. So I need the x-axis and the y-axis. So you're definitely to the right of this and above that. The only question is it below this one? If so, then it's enclosed. Or if it's greater than going that way, it's going to be unbounded forever. But it is less than or equal to, and it's no chance for it to flip. So we are the enclosed version that. It's enclosed right there. If I painted up here, then it would be unbounded and there'd be no maximum. Because I painted below and stayed within the x and the y-axis, this is an enclosed region. We're guaranteed to get a max and a min now. And the good news is they only occur at what they call corner points. Corner points of your solution, of your shaded area. So my shaded area is a triangle. There's 3 corner points. This one, and this one. And they're all very easy to see on the graph. Sometimes if you get multiple lines going on, they're a little hard to tell, but this is when they're all easy. This one is 0, 4. This is clearly 0, 0. And that one is 6, 0. And it's important on the intercepts to put the 0 in the right place. An x-intercept has a 0 for y. A y-intercept has a 0 for x. These 3 points, one of these 3 is the maximum, one of these 3 is the minimum. There can be a tie, so there could be a situation where you get 2 points that are tied for the maximum, or 2 that are tied for the minimum. Here we can't get 2 for the max and 2 for the min, but probably what's going to happen is one will be the max, one will be the min, and the other one will be nothing. That's usually what happens when there's 3 corner points, but it could be tied. There could be 2 tied for the most. But even if there is a tie, the maximum only is happening once. There's only one maximum value and there's only one minimum value when you have an enclosed region. It's just that multiple corner points could give you the same max or min value. And so, okay, we did that. The solution of the region is bounded, so then I know there is definitely a max and a min. What are the coordinates of each one? So this is what I listed: 0, 0, 0, 4. Whoops, didn't get the parenthesis right. 0, 4, and 6, 0. So you don't know yet how to find the max or min. That's probably coming up next or soon after this one. But this is the majority of the rest of this section 5.2. Is you draw your graph, shade it, and then you hope that it's enclosed. Or maybe you hope it isn't, because if it isn't, then you get less answers. But if it is enclosed, then you're going to definitely get a max and a min. And they need to give me more information to be able to do that, so that'll be coming up tomorrow. But at least we're halfway done with, yeah, see, this is similar, but it has more equations. So we don't know that part yet, but we'll get to it. So we are halfway done with this week 5 homework, which had less sections to cover because we knew the final exam was happening this week. So this was Monday, August 15th. We did 1 through 15. Tuesday, August 16th, we'll do 16 through 30. And that'll be the end of the homework. And then on Wednesday, we can do all 25 of these in one video. And this is kind of like, the one good thing about the final is that it doesn't have all the hardest problems of each section. You get kind of like the basics of each section. There's basically one problem from each section that we learned. Okay, so that's it for Monday, August 15th. Monday, August 15th, we're done. 2 more videos to go, Tuesday and Wednesday of this week. So I'll see you tomorrow for Tuesday, August 16th, Math 1324.